So moving forward with the idea of cracking. Now this is basically a process where we take large molecules of hydrocarbon and break them down into smaller molecules of hydrocarbon. And the idea basically behind this is that when you have crude oil, or when we talk about fractional distillation of crude oil, so there are some large molecules of alkanes. That usually these larger molecules are alkanes. So these large molecules of alkanes, they are not useful for us. Okay, and in order to make them useful, we have to bring them through the process of cracking and then break them down into shorter molecules of both alkanes and alkenes. And this is the whole idea about cracking. So if I were to write this in terms of just general perspective, this basically is large hydrocarbon molecules. Sorry. And these molecules usually will always be alkanes. So we take large hydrocarbon molecules, which are alkanes, and by the process of cracking, so we do the process of cracking, and we bring them down into short hydrocarbon molecules, right? And these short hydrocarbon molecules, these are either, you can say, an alkene plus alkene. Okay, and also the products that is formed is hydrogen gas, right? So this is the whole idea about cracking, and the purpose we actually need to do it. The reason we do it is because, again, as I said, the large molecules of hydrocarbon are not useful to us, but when we break them down to smaller molecules, or smaller short hydrocarbon molecules, then those molecules are really useful for us. One of these molecules are actually used as fuels. So, for example, short chain alkanes that is used as petrol. If I talk about short chain alkene molecules like ethene and all, these are starting materials for a lot of industrial processes. So then we go from being not useful to being useful. So this is the complete idea. Now, if I were to write this in terms of, let's say, equation, so a chemical equation would be, let me take a molecule that's called, let's take C6H14. Now, this is an alkane molecule, a large alkane hydrocarbon molecule, whatever. Okay, and this is basically hexane. Okay, so now the process of cracking starts. Now here the process of cracking is happening, and this is now going to get broken down into an alkane and an alkene molecule. So what happens? Now you have, once the process of cracking happens, now you'll have C4H10 plus C2H4. So you form an alkene molecule. Now this molecule is, butane, and you form an alkene molecule, which this is an ethene, right? So what happened? You started from a long hydrocarbon molecule, which was hexane, C6H14, and you break it down, or by the process of cracking, you break it down into an alkane and an alkene molecule, right? Which can be a butane, which on the product side is butane and ethene in this condition. Now, this can differ. Now, this combination can differ. What do I mean by that? It doesn't necessarily have to break down into these two molecules. It can be any alkane or alkene molecule. Like, for example, if I were to say that, okay, again, we take hexane. Now, I'm just telling you in how many different molecules can this break into. So you can also have C3H8 plus C3H6. Okay, you can also have C2H6 plus C4H8. Now, this hexane molecule can also be broken down like this and also be broken down like this. All of these three are correct. And why is it correct? Because we don't know. Once the cracking happens, we never know the molecules or the combination that is going to be formed. So we just take it. The only thing that you need to be careful here is that you need to match the number of carbons and hydrogens that you started with. So let's say you started with 6 carbon here and 14 hydrogens here, and you ended up with 6 carbons and 14 hydrogens. That's the only thing that you need to take care of. Okay. The same way, you have 3 carbons here, 3 carbons here, that makes it 6, and you have 8 hydrogens here and 6 hydrogens here, that makes it 14. So you ended it what you started with. Okay, so the count has to be equal, and this is different combinations that you can find. Now this molecule here is propane, right? And this is propane. This molecule is ethane, right? And this here is butane. And that's the beauty of it. You can have different combination. It doesn't have to be one single combination. All of these three are correct. Whenever the question comes in cracking, you just need to know. You just need to remember that you have to match this with this. Okay, so the number of carbon and hydrogen should remain the same in the overall equation. That's what you really need to take care of. And yeah, one more thing that I missed in this is, now this process of cracking, this does not happen without any reagent. So here you're going to need a catalyst. Okay, you're going to need a catalyst. You're going to need 1 atmospheric pressure, and you will also need 500 degree to 700 degree centigrade of temperature, high temperature. This is how this reaction is going to take place. And once we involve a catalyst, now we're going to call this catalytic cracking. Okay. Once we involve catalyst in the process of cracking, we're going to call this a catalytic cracking. And the catalyst that we use, these are Al2O3, which is aluminum dioxide, and SiO2, which is silicon dioxide. So this is the whole idea about cracking. I hope I haven't missed anything here. And just to give you the right idea about this, so let's say I was talking about making them into more useful products. So here, if you talk about once we have broken down the molecules, at a lot of places you form ethene. So see, you form an ethene here. Now ethene is a molecule that is used for many industrial products, for starting off a lot of industrial processes. Okay. As the same goes for propane. Propane and ethene are both molecules that are used for industrial processes. And the short chain hydrocarbons, which are alkanes, now these are basically your fuels. These are basically what we use as fuels. That's petrol. Okay. So if I were to just write the last thing, which is the general idea of the equation, that's going to look something like this. I'm sorry. Okay, so how does that look like? So you have an alkane molecule. You start with an alkane molecule. Okay, and the process of cracking happens. You're gonna form something that we call, now here, another thing that you need to keep in mind, it's not another thing basically, it's just what I've already told before as well. This here is going to be short, not chain. I don't know why I keep writing chain, but this here will be, oh yeah, it's actually chain. Sorry. Short chain mixture of alkanes, because there are going to be different alkane molecules that will be formed. As we saw, we had C4H10, we had C3H8, we also had C2H6. We had different molecules being formed. Plus, one product is going to be this, and the other is going to be again short chain mixture of alkenes, or either you have a short chain mixture of alkenes, or you're gonna have hydrogen gas. Right? Yeah, that's about it. Oh, actually, I just wrote this the other way around. So you're gonna have a short chain mixture of alkenes. Just a second. We're gonna have a short chain mixture of alkenes, and you're gonna have a short chain mixture of alkenes here, or hydrogen gas. So this is how the composition looks like. And you can, instead of writing alkane molecules, you can write, you can write long chain alkanes. It doesn't matter. You can write the same thing. So that's about it. That's about the whole process of cracking. And if I just go to just write catalyst, you need a catalyst, you need 1 atm pressure, and you also need 500 to 700 centigrade of temperature. Again, then you're going to call this catalytic cracking, as we discussed. Right? So this is the idea of cracking. I hope this is clear.